Hello students, let's talk about lab number 15 where we are troubleshooting a parallel only circuit. This is a circuit that we built in lab 14. We have 3 resistors in parallel, which are 270, 560, and 680. I will have this available on the portal. And I've changed, I wanted to indicate in both those labs, I've changed the power supply to 6 volts just because that's a source that was readily available in a lantern battery. And so as you can see is that sometimes for simplicity and a visual effect, what we're going to do is we're going to put 3 diodes in here and then we're going to analyze this circuit. So this is a circuit that we just built. These are the numbers if you were to do some calculations to look at and see what happens is that my smallest resistor has the most current through it, or in the largest resistor has the least amount of current. Total current is around 42 milliamps. And what I've done for visual effect is I've went ahead and built this circuit. It's a little bit different than our schematic. I put the LEDs on bottom, and I've taken out of our jumpers of our previous circuit and just bus lined these together. So as you see, as I attach these 3 resistors in parallel, is the LED light comes on. What I wanted you to realize is that one of the characteristics of a parallel circuit is that branch current's independent of any other branch. So what I mean by that is if I were to take out this resistor R3, the current quits flowing. There's no component for the current to flow through. I've disconnected that LED from the circuit primarily. But if you look at R1 and R2, is that both those LEDs are still working. So I still have 6 volts applied across this network here. There's 6 volts if I were to measure across this LED in the top of the resistor, which means that the current flowing through there would be the same, regardless of whether R3 is in the circuit or not. So we certainly can put a pen and paper and a calculator together and figure out what's wrong. If I look at my numbers here, the way I would find out that R3, if the LEDs weren't in there and give me a visual cue, is that I would look at my total current. My total current here is about 42 milliamps. The current going through R1 is almost 9 milliamps. So if I were to measure total current and get 32 milliamps, I would say, okay, which resistor has 9 milliamps going through it? And I would see that that's R3. So it would be a good indication that R3 is open. And that's how I would analyze that circuit. So we're going to do this in laboratory. We'll put this together and take a look. The LEDs there are basically just for a visual effect to show you that current is really flowing through that circuit. And the way we analyze which branch is open is the current that is missing. If you look at total current and the current's missing, the difference between those two, whatever current is running through that branch and is missing, tells you which one of those branch currents is open. I hope this helps. I look forward to seeing you in lab.